cosmic nurseries, where stars take their first breath. Space is vast, really, truly vast. It's a realm that stretches beyond our wildest imaginations, a seemingly infinite expanse that holds countless mysteries and wonders. You think it's a big deal to drive across the country? Try wrapping your head around the distances between stars. We're talking about light years. Distances so immense that light itself, traveling at 186,000 miles per second, takes years to traverse them. But here's the thing, even in this seemingly empty expanse, stars are constantly being born. It's a process that defies the emptiness, a testament to the dynamic and ever-changing nature of the cosmos. Picture giant clouds of gas and dust drifting through the cosmos. These are nebulae, the stellar nurseries of our universe. Within these vast clouds, the seeds of new stars are sown. Now, imagine a cosmic wind blowing through this cloud, stirring things up. This wind, often driven by the energy of nearby stars or supernova, creates ripples and waves within the nebula. Gravity joins the party, pulling particles together. It's an invisible force, but its effects are profound, drawing matter into tighter and tighter clumps. Slowly, these clumps of gas and dust start to heat up and spin. The friction and pressure within these clumps cause temperatures to rise, setting the stage for something extraordinary. Like a cosmic snowball rolling downhill, they gather more and more material, growing denser and hotter. This accumulation is a slow but relentless process, driven by the inexorable pull of gravity. This process can take millions of years, but trust me, it's the ultimate slow-cook recipe. Over time, these clumps become so dense and hot that nuclear fusion ignites within their cores. These clumps, my friends, are protostars, the seeds of future stars brimming with potential energy. They are the precursors to the brilliant stars that light up our night sky. And just like any good recipe, there's a whole lot of fascinating science happening behind the scenes. The interplay of gravity, pressure, and temperature creates a delicate balance that leads to the birth of a star. So next time you gaze up at the night sky, remember those twinkling points of light aren't just decorations. They're active, evolving entities, each with a story to tell, a history as vast and mysterious as the universe itself. Each star you see has undergone this incredible journey, from a cloud of gas and dust to a shining beacon in the cosmos. And who knows? Maybe one day, one of those stars will have planets orbiting it, with life forms looking up at their sky, wondering about the stars just like we do. Baby steps, the protostar phase. Protostars, those bundles of stellar potential, aren't quite stars yet. They're like teenagers figuring things out, going through a phase, pun intended. They're still gathering material from their surroundings, their cores getting hotter and denser by the minute. Talk about pressure. This isn't just some random cosmic heating process, though. As the protostar contracts under its own gravity, the atoms inside start bumping into each other with increasing ferocity. It's like a cosmic mosh pit down there, and things are about to get wild. Eventually, the core of the protostar reaches a critical temperature, a scorching 10 million degrees Celsius. This incredible heat ignites nuclear fusion, the process that powers stars. Hydrogen atoms, the smallest and most abundant in the universe, are forced to fuse together, creating helium and releasing an incredible amount of energy. Now this is where things get really interesting. This energy, my friends, is what makes a star shine. It's the cosmic engine that drives the life cycle of stars, and ultimately, the evolution of the universe itself. A star is born, reaching the main sequence. The moment nuclear fusion kicks in, a star is officially born. This is a monumental event in the life of a star, marking the transition from a mere collection of gas and dust to a radiant celestial body. It graduates from being a protostar to a full-fledged star, taking its place on the main sequence. This journey from a protostar to a main sequence star is a complex process involving gravitational collapse and nuclear ignition. Think of this as the cosmic equivalent of adulthood. Just as humans mature and find their place in society, stars reach a stage of stability and balance. The star has found its groove, achieving a delicate balance between gravity pulling inward and the outward pressure from nuclear fusion. This equilibrium is crucial for the star's stability and longevity. This main sequence is where stars spend the majority of their lives. It's a period characterized by sustained nuclear fusion, where hydrogen is converted into helium in the star's core. It's a period of relative stability, but that doesn't mean it's boring. During this time, stars can exhibit fascinating phenomena such as sunspots, solar flares, and even coronal mass ejections. Stars on the main sequence come in a variety of sizes, temperatures, and colors. From the massive hot blue giants to the smaller, cooler red dwarfs, the diversity is astounding. Our own Sun, a yellow dwarf star, is a prime example. It sits comfortably in the middle of the main sequence, providing the perfect conditions for life on Earth. But don't let the dwarf label fool you. Despite its name, a yellow dwarf like our Sun is incredibly powerful and plays a vital role in the solar system. Our Sun is still a mighty force, fusing 600 million tons of hydrogen into helium every second. This process releases an enormous amount of energy, which we experience as sunlight and warmth. That's the power of nuclear fusion, folks. It's the engine that drives the star, enabling it to shine brightly for billions of years. It's what allows stars to shine for billions of years, bathing the cosmos in their light and warmth. This light travels across vast distances, illuminating the universe and providing a glimpse into the past. And just like humans, stars have a limited lifespan, determined by their mass. The more massive the star, the shorter its life, as it burns through its nuclear fuel more quickly. But that's a story for another time. For now, let's appreciate the incredible journey of a star reaching the main sequence, a testament to the wonders of the universe. Section 4. Living on borrowed time, nuclear fusion in action. We've established that stars are basically giant fusion reactors in space, but let's delve a little deeper into the magic happening at their cores. Imagine the core of a star like a cosmic pressure cooker. The immense gravity creates intense pressure and heat, forcing hydrogen atoms to overcome their natural repulsion and fuse together. This fusion process releases an incredible amount of energy, primarily in the form of light and heat. This energy then radiates outward from the core, making its way through the star's layers until it finally escapes into space. And that, my friends, is what we see as starlight. But here's the catch: stars are constantly losing mass. Every time fusion occurs, a tiny bit of mass is converted into energy. It's like the star is slowly burning its own fuel, and just like any fire, eventually the fuel runs out. What happens then? Well, that depends on the star's mass, leading to a fascinating array of stellar endgames. Section 5, stellar variety, red giants, white dwarfs, and everything in between. Stars are not one size fits all. They come in a stunning variety, each with its own unique characteristics and evolutionary path. From the moment they are born in vast clouds of gas and dust, stars embark on journeys that can lead to vastly different outcomes. Think of it like a cosmic family reunion. Each star has its own story, its own quirks, and its own destiny. You've got your average Joes like our Sun, but then you've got the giants, the dwarfs, and even some exotic characters you wouldn't believe. Each type of star plays a unique role in the grand tapestry of the universe. Take red giants, for example. These are the elder statesmen of the stellar world. These massive stars have exhausted the hydrogen in their cores and start fusing helium. This process marks a significant phase in a star's life cycle. This causes them to swell up to hundreds of times their original size, engulfing nearby planets in the process. Imagine a star expanding so much that it could swallow entire planetary systems. Talk about a bad day for any life forms in the neighborhood. The sheer scale of these events is mind-boggling. Then you have white dwarfs, the stellar remnants of stars like our Sun. These are the final evolutionary state of stars that were once similar to our own. These are incredibly dense objects, about the size of Earth, but with the mass of our Sun. The density of a white dwarf is so extreme that a single teaspoon of its material would weigh tons on Earth. Imagine squeezing all that mass into a tiny ball. The gravitational forces at play are immense. That's a white dwarf for you. Despite their small size, they are incredibly powerful and can even lead to spectacular supernovae under the right conditions. And these are just two examples. The universe is filled with a myriad of stellar objects, each more fascinating than the last. The universe is teeming with neutron stars, pulsars, and even black holes, objects so dense that not even light can escape their gravitational pull. Neutron stars, for instance, are the remnants of massive stars that have exploded in supernova. The diversity of stellar objects is a testament to the incredible power and complexity of the cosmos. Each type of star, from the smallest red dwarf to the most massive supergiant, contributes to the rich and dynamic story of our universe. The study of these celestial bodies not only helps us understand the life cycles of stars, but also the very nature of the universe itself. As we gaze up at the night sky, we are reminded of the vastness and diversity of the cosmos. Each point of light represents a star, a story, a piece of the cosmic puzzle. The more we learn about these stellar objects, the more we appreciate the intricate and awe-inspiring nature of the universe. So next time you look up at the stars, remember that you are witnessing the incredible variety and complexity of the universe. From red giants to white dwarfs and everything in between, the cosmos is a never-ending source of wonder and discovery.